Welcome to the session on power structure and thermal power plant. Let me discuss first the power structure of a power system, how the generation, transmission, and distribution process happens. So, let us talk about the power system grid. What is power system or grid? The system of high tension cables by which electrical power is distributed throughout a region. So, grid is a point where the distribution of power happens to different regions, and grid is a point where the generations of various resources can be given to the point. So the locations of power stations are dash from dash, thus exits large dash between the power stations and the consumer. So if you want to fill up this, normally the power stations are located very far from the consumer end. Um, so consumer end is the demand end. So thus exists a large network of conductors between the power stations and the consumers. So we have basically three major parts in the power system, that is generating station, transmission network, and distribution network. So coming to the typical transmission and distribution scheme, you can see we have a generating station where the generating station generates a voltage of some standard electrical voltages like 11 kV, 22 kV, 33 kV. So depending on the standards of generating voltages used, so example say 11 kV, they first step up using a transformer to 220 kV. So from 11 kV to 220 kV, it is been stepped up. So the stepping up is done for the reason where there are a lot of advantages before transmitting via the transmission tower. So stepping up to a very high voltage have a very good advantage, like economically feasible, and losses are less, and thus then the power transmission happens through the towers, uh, the high voltage, the through the towers, and it is given to the different receiving stations here. So I'm showing up two different receiving stations, there can be three also. So before it reaches the receiving station, either of these, it is further stepped down from 220 kV to 33 kV. So whatever the stepped up voltage from the generation, that is 220 kV, is now stepped down to 33 kV. Again, depending on the required voltages, it can be 33 or it can be 66 kV as well. So then after stepping down, it is given to the receiving stations of consumer network. So from the receiving station via the feeders, it is given to the substations. So different substations receives the power, the power through the feeders. So from 33, it is further stepped down to 6.6 at the substation level. So from the substation, it is given to the bulk load consumers. So for example, we have bulk load consumers factories like cement factories, steel factories, and other high voltage consumer factories. They can be given the voltages from the substation directly via the feeders for bulk consumers. So further from the substation, it is given to the distribution transformer, so where 6.6 kV is stepped down to 230 or 400, that is the normal operating voltages for a domestic and industrial purposes. So it is then distributed via the service mains to the different consumers. So generating station will have basically the primary transmission, secondary transmission, primary distribution, secondary distribution, and now this is the single line diagram. The earlier was the basically how the network exactly would be in the power system. So that is a pictorial representation. Now coming up, since we cannot have the pictorial representation to explain, we further resolve that into simple single line diagram where the single line diagram appears like this. So we have a generating station, as I said, at 11 kV. So this circle enclosed with symbol of sine wave represents an AC generator. So symbolically for the machine, we represent a circle. So inside it can be a sine wave represents a generator. So with that, we have a step up transformer. The winding, at the primary side is less comparatively to the secondary side, because primary side the voltage is 11 kV and the secondary side it is 220. So stepping up to a very high voltage, the secondary side should have a very number of turns more than the primary turns. So from there actual the primary transmission happens. So this happens at a very high voltage of 220 kV. As I said, this is given to the receiving station which are operating at different voltage level. For example, 66 or 33 kV. Here we have shown 33 kV, the electrical standard voltages. So from 220 it is stepped down to 33. As you notice, 220 has a more winding than 33 kV. So from there, after receiving station, it is further transmitted, that we call it as secondary transmission to the substation. So where we step down again from 33 to 6.6 kV. So 6.6 kV can be given to the large bulk loads like factories, industries, so large scale industries, medium scale industries which operate at 6.6 kV, or 3.3 further it can be stepped down and given it to the industries. Now we have a primary distribution happening, before giving it to the distribution station. So from the distribution station, the distribution station where we step down further 6.6 to 400 or through 230 volts, where the normal operating voltages for commercial and domestic purpose will be 230 single phase and 400 as three phase. So the secondary distribution happens from the distribution station to the different consumers via the service mains. So this is a typical general structure of electrical power system using single line diagram approach, where we can explain the different transmission and distributions happening from generation to the consumer level. So coming up to the sources of electrical energy, how the electrical energy is being produced. So let me take up the first approach using a thermal block diagram approach, where steam is used to rotate the turbine and the electrical energy is produced. So steam power plants works on the process of Rankine cycle, where the thermal power plant requires the basic parameters or inputs. We need to have a coal to burn and get the water to boil, and then the steam out of the boiling water is being used to rotate the turbine. So we have a boiler where the water is placed, superheaters, economizer, air preheater, steam turbine, alternator, condenser, and feed water pump. So working, and it should always be maintained at a particular pressure, and also we use a type of cooling system in the thermal power plant. So let us explain one by one. So we have a coal storage here. So coal storage is then used to pulverizing mill or coal, where we burn the coal, and that heat is given to the boiler, where we have a boiler tubes, and the water boiled here will produce a steam, where this steam is given as an input to the steam turbine, where the turbine blades rotate at a particular speed. And remember, the steam has to maintain a particular pressure, and then the steam turbine rotates, where the shaft of the steam turbine is connected to the rotor shaft of the generator, which makes the generator to rotate and thus produce an electrical output of 10 to 30 kV. So that is given to the grid, or or to the bus bar. So we have a protection devices like circuit breaker and switch gear, and also stepping up the voltage from 30 kV or 10 to 30 kV to 220 to 400 kV. As I said, that has to be stepped up and then transmitted via the bus bar. So we, whatever the coal burned here, will have a hash collecting, and that is, we have a hash handling plant where we have a hash storage to be made. So uh, care to be taken where disposing of ash is also been taken care very carefully. So cold storage also has a very important role where we need to handle the coal, and it has to be stored in a particular place where it has not been exposed to moisture or wetness condition. So cold storage, then coal handling, then it is given to the boiler where it is burnt, and the heat is given to the boiler where the boiler produces a steam which has to be maintained at a particular pressure, which is given to the superheaters to maintain a particular pressure, and then given to the turbine where the turbine rotates at a particular steam pressure, and then which in turns rotate the alternator rotor shaft which is connected to the turbine, producing a electricity. So this is producing the electricity and given it to the grid. So three phase generation is happening here in this approach. So the from the turbine, the remaining steam, or it is collected and it is given to the condenser to cool it, and then it is further given to the cooling tower to cool, and then it is given to the cooling water pump. So it is given back to the condenser and it is recycled and given it to the feed water pump to feed the water into the boiler. So we can give it to the water heater and economizer again to bring to the required you know um, uh, heat, and then given to the boiler where it can be reused again. So gases are also from the boiler is escaped through the superheater and economizer via the chimney. So we have chimney also. We need hair preheater and draft fan to cool it. So hot hair which is getting cooled and it is given to the boiler again. So ash handling, as I said, once it is burnt, it has to be handled in a very very efficiently, and it is properly disposed. So advantages and disadvantages of thermal power plant, where thermal power plant converts the heat from burning coal into electrical energy. They can be set up anywhere near a fuel and water supply. So advantages includes it is a quick startup, economies of scale, less space required than any other power plant, cheapest fuel cost where coal is very cheap comparatively to other resources, I mean except hydro. So cheaper production cost than diesel power plants. So disadvantages is we need to depend on fuel, that is coal, and the land required for the thermal generation is also vast because we need to handle the ash disposing and cold storage. So water use, high initial cost, overall efficiency, high maintenance cost, air pollution from smokes, difficult fuel and ash handling. So that is all about the power system structure and the generation of thermal power plant. Thank you for watching this.